1 over r, I will write this thing is equal to, when this thing is equal to L into L plus 1, so I can write that partial over partial r and r square, partial r over partial r here is equal to L into L plus 1 times r here. This is the first equation that I have. And what about the next one? The next one will be 1 over r. If I even move sine theta on that side, then partial over partial theta is in sine theta, partial theta over partial theta here is equal to minus L into L plus 1 and sine theta, big theta here. We will have to keep another thing in mind, and that is that the partial differential equation, when we separate, then it converts into the ordinary differential equation. So wherever we are having partial over partial r or partial over partial theta, then it will convert into d over dr, and here it will convert into d over d theta. And so we now start with the very first equation, which is the d over dr and r square dr over dr, and this is equal to L into L plus 1 and r here. So we will have to, this is the radial part of the equation, and we will have to solve this equation. Unfortunately, in Griffiths, again, this equation has not been solved. So if you are interested to solve this equation, then I am providing you a link of the J.D. Jackson classical electrodynamics, where we have solved this equation with the help of power series. So you may see there that how this equation is derived in detail, but I will not go into that one because it will go out of the limit of this course. However, I will discuss the solution, that the solution of this equation is this r means a function of r, then this implies that the solution of this is r. It's a second order differential equation, and in second order differential equation we'll have two solutions. So r of r is equal to a constant. Usually we put a constant and then the variable, which is r, and it is having power L, plus b, and it is having r minus L plus 1, b and r, and this is minus L plus 1. Sometimes we write it in this form as well, that a r to the power L plus b, another constant, undetermined constant, and r to the power L plus 1. Now here, if I look to this solution, then this one is the growing solution, means it is r to the power L. As L increases, r is blowing up, and this is the going to zero solution, because as L increases, then r, this is 1 over r, so it will go to 0 here. So we are having this solution. This solution we have derived over there with the help of power series, that yes, this is the solution. But here, looking to the limit of this course, we are not solving it. And then we come to the next equation, and the next equation is d over d theta, d over d theta. and sine of theta, curly theta by curly theta. So it will also become d here, d over d theta, and equal to minus L into L plus 1 and sine of theta and big theta here. Now again we have not solved this solution here. We will write the direct solution, and the reason behind that one is the previous one, but I'm providing you a link where you can see that how this equation is solved and how this equation gives us the Legendre polynomials in the Rodrigues formula, with the help of which which served as a solution of this. So the solution of this equation is the Legendre polynomial theta of theta, and this is equal to PL of cos theta. PL of cos theta, these are basically the Legendre polynomials. And one thing we will have to keep in mind, which I will explain, where the in PL of x or this, we know that we are having in a circle. In a circle, we are having in the when we convert, circle is a two-dimensional, and when we convert the Cartesian into polar coordinates, then we are having the relations is x equal r cos theta and y equals r sine of theta. Now when we consider a unit circle, then in unit circle this r goes to 1. So we have x equal to cos theta and y equal to sine theta. These are basically the conversions we do. So this theta of theta is PL cos theta, and in terms of x, if I want to write this thing, then it will be PL of x. And PL of x in the form of the Rodrigues formula, I can write that PL of x is equal to 1 over 2 per L and L factorial d over dl d over dx, because I will have to write this in the form of x, d over dx, and this is having power L, means the order of derivative is L, and x squared minus 1 to the power L. When these two parts are the same, then it means it will give us a constant. When these two parts, this one becomes greater than this one, then it will give us 0. When this one is less than this one, then it will give us a variable. So this is something that we will have to see in a while, that why this thing is happening. We can try this one. We will have some conversion here as well. So let's see that how the few Legendre polynomials that I do calculate here, it will be, just look here, that if I write P naught of x, then P naught of x will be, L will be equal to 0. So when L is 0, then 1 over 2 power 0 is 1. 0 factorial is 1. So this whole becomes 1. And when I come here, then the derivative power is 0. It means it is 1. And here it is 1. So this all will give me 1 here. And when I write P1 of x, then P1 of x will come out to be, this will be 1 over 2 power 1, and 1 factorial is 1, so I will have 1 over 2. Then I will have the d over dx to the power 1, and here it will also be to the power 1. So it means it is first order derivative of x square minus 1, and first order derivative of x square is 2x, and this one is 0. So we are having 2x here, and 2x will come here, then 2 is gone with 2, and we are left with x. So P1 of x is equal to x. Similarly, you can calculate very easily P2 of x, what it will be. Then P2 of x will be, it will become 1 over 2 to the power 2, so it will 4 into factorial, it will become 2, so 2 into 4 will be 8, we will have 1 over 8. Then second order derivative of x square minus 1 to the power 2. So we will have to first calculate the 2 power, and then we calculate this derivative. Or we just do 2 here, and then x square minus 1 will come, 2 minus 1, and then of the x square we have 2x. So both ways we can do calculate, and we will see that this one comes out to be 3x half and 3x square minus 1. Similarly, you can calculate all the polynomials, like I am writing here is per your book the phi5 of x. You can do verify them. There is no concept involved here, but just you will have to do the calculations, only hard work is there. So this is 1 over 8, and this is 63x squared, x5 minus x5 minus 70x cubed and plus 15x. So this will give you up to 5 polynomials. Sometimes we do write this thing in the form of cos theta. So here, when this is equal to 1, then 1 for the x r for this will be the same, while here it is x, so x means that this is equal to cos theta. Similarly, when this is 3x square minus 1, so this is basically 3 cos square theta minus 1, and sometimes we utilize some trigonometric identities to convert this into another form. So this way we have found the solution of the Laplace equation with azimuthal symmetry. So finally I can write the final solution is equal to V of r theta is equal to a r to the power L plus b r to the power L plus 1. This is the radial part solution, and then we are having PL of cos theta. This is the angular part, means only the theta part solution here. We have already considered the azimuthal symmetry. Now we will have to determine in this solution the constant a and b, and then we will be able to go towards the solution. But here we will have to keep one thing in mind, that L here is not a single number. It is basically running from values which are from 1, 2, 3 and so on. So we will have running from 0 to 1, 2, 3 and so on. So better we write this in the form of summation, and V of r theta is equal to summation on L running from 0 to infinity, and a r to the power L plus b and r to the power L plus 1, and then PL of cos theta. Now this is the solution that we have derived, and to observe the power of this solution, we will solve an example on this one, and then we will come to know that how powerful is this solution. So again, in a review, if you want to see the details how these solutions are being derived and what are the calculations involved, there are, keep in mind, a lot of calculations involved, and means hours of lectures are done, and then we reach to a certain solution. So if you are interested, I have provided you the links earlier, then you can go and see that how these equations are being solved. So the next we will solve example 3.6 on this one in order to see the power of this solution.